adding and subtracting polynomials. A polynomial is an expression with two or more terms. So an example would be x plus y plus z. So this is a polynomial because it has three terms. Polynomial. So each term is separated by a plus or a minus sign. Now we can add two or more polynomials together. So an example of a separate polynomial grouped together by parentheses would be 2x plus 3y, and this polynomial has only two terms. So this is an example of what adding and subtracting polynomials is going to look like before we start to actually add or subtract the terms. So the basic idea of adding and subtracting polynomials is that you're combining like terms. So that like terms is going to be important. So let's do an example. Hey, if I give you 2x plus 4y, this is a polynomial with two terms, and we want to add the polynomial x plus 2y. So here we have a polynomial with two terms, and we're adding another polynomial with two terms. The process of adding these polynomials is to look at the like terms. So I have 2x, and here I have the term x. Now anytime we have a polynomial with a term that does not have a coefficient or a number in front of the variable, it's understood to be a 1. So if we were to add these two together, 2x plus 1x is 3x. We'll do the same with the terms that have a y. So here we have a positive 4y, and we're adding a positive 2y. So positive 4 plus positive 2 is a positive 6y. Now notice that we cannot combine our final answer, 3x plus 6y. We cannot combine 3 and 6 because they are not like terms. 3x has a variable of x, 6y has a variable of y, and since those variables are not the same, we cannot add them together. So our final answer will stay 3x plus 6. This was an example of adding two polynomials. Now, let's look at an example where we might have negative coefficients. And what I mean by that is if I give you the polynomial negative 2x plus 5y, and we want to add the polynomial 4x minus 2y, notice that I'm still adding this polynomial and this polynomial, but I have some negative coefficients within the polynomial. We're going to go through the same process of identifying like terms. So we have negative 2x and 4x. When we add these together, we have to keep in mind negative 2x plus 4x. That's going to give us negative 2 plus 4, which is a positive 2x. Then we'll move on to positive 5y plus negative 2y. So if we're adding 5y plus negative 2y, anytime you're adding a negative, this is essentially 5y minus 2y, which is positive 3y. So our final answer here is 2x plus 3y. We cannot combine these terms because they have different variables, which means they are not like terms, and we cannot. Next, we have an example of subtracting two polynomials. So we have the polynomial x plus 2y, and we are subtracting 3x minus 6y. Something important about the subtraction between these two polynomials is that you're subtracting 3x and subtracting negative 6y. So what happens then is we can bring down the first polynomial. Then we're going to think of each term in the second polynomial individually and subtract both of them. So if we're subtracting 3x, that would be a minus 3x. And if we're subtracting a negative 6y, we could write it as minus negative 6y. This looks a little bit messy, so we want to clean it up. And to do that, we can think about what is actually happening when we subtract a negative value. So we'll leave the first polynomial the way it was, x plus 2y minus 3x. Then when we have minus a negative number, the operation is addition between those two values. So we can write that as x plus 2y minus 3x plus 6y. So to simplify this, we would still be looking for like terms. So I'm looking for my terms that have the variable x. So we have an x and a negative 3x. So if I have an x with no variable in front, if I have an x with no coefficient in front, it's understood to be a 1. So we have 1x minus 3x. 1 minus 3 is a negative 2, so that's negative 2x. Then looking at the terms that have the variable y, we have a positive 2y and a positive 6y. When we add positive 2 plus 6, that gives us a positive 8y. So our final answer for this one is negative 2x plus 8y. We cannot combine anything else because they have different variables, so we will leave them as the polynomial negative 2. An application of adding and subtracting polynomials is found in perimeter problems. Let's look at this one and see how adding and subtracting polynomial shows up when we have information about the perimeter of a figure. We have a triangle, and we are told two of the sides of a triangle are 2x plus y and 5x minus 2y. So these polynomials represent two of the sides of this triangle. I'm going to label two of those sides accordingly. And we're told the perimeter of the triangle is 10x plus 3y. When you see the word perimeter, all that means is the sum of all the sides in the figure. What is the value of the missing side? So we need to know what is this value of the side that we do not have the value for. Well, we know that if we were to add all of these sides together, this side plus this unknown side is a sum of 10x plus 3y. So if we were to add 2x plus y and 5x minus 2y and the question mark, that would be equal to the perimeter of 10x plus 3y. What we can do with this information is say that this missing side is the perimeter minus these two sides. So we can simplify this equation that we have by adding these two polynomials together based on what we know about adding polynomials. So we'll look at any like terms and combine them first. I see terms that have the variable x. So 2x plus 5x is 7x. And I see variables y. So we have the term y and the term negative 2y. Since this y does not have a coefficient, we can understand that it's a 1. So positive 1y minus 2y is negative 1y, or just negative y. So this polynomial plus the unknown side is equal to the perimeter. Now, if we subtract this polynomial from both sides, or in other words, if we subtract this sum of these two sides, it will give us this missing side. So if we treat this like an equation, 7x minus y minus 7x minus y is 0. So our question mark is simply the perimeter minus the sum of these two sides. So if we were to subtract these polynomials, we would have 10x minus 7x. So 10 minus 7 is 3. Then the next part, we have to be very careful because we have 3y. We have 3y minus negative y. So 3y minus negative y. Again, anytime you have minus a negative number, the operation is addition. So 3y plus y, or 3y plus 1y, is 4y. So we have 3x plus 4y is the missing side. You can check this by adding all three of these sides together. You could add this plus this plus this should equal 10x plus. When multiplying polynomials, we will use a process called the box method, and this just gives us a way to organize the information so that we don't make any careless errors in the process of multiplying polynomials, because there are several steps involved. So if we have a polynomial, let's say x plus 1, and we're multiplying this polynomial times the polynomial x plus 2. The first step you might think of doing is multiplying x times x and 1 times 2. That is incorrect. So before we move any further, I just want to make sure that we understand we are not only multiplying x times x and 1 times 2. The box method keeps us from making this mistake. The box method allows us to set up a box that would be 2 terms high and 2 terms wide. So since we have 2 terms and 2 terms, we're going to set up a 2 by 2 box. So 2 by 2 box. That means when we draw the box, it needs to be large enough that we can fit 2 terms across the top and 2 terms down the side. So I have split mine up so that I have 2 spaces on the left of the box and 2 spaces on the top of the box. In those spaces, I'm going to put the terms from the polynomials that we're multiplying. So on the left, we'll put the term x and the term positive 1. At the top, we'll put the term x and the term positive 2. Now what happens is we are multiplying each term within the box. So first we'll look at x times x. So anytime we are multiplying a variable times itself or a variable times the same variable, we have to keep in mind that when we do that, we really are multiplying x to the first power times x to the first power. When we multiply x to the first power times x to the first power, that gives us x to the second power because we are adding these exponents together. Next, we will multiply x times positive 2. So 2 times x, or x times 2, is simply 2x. Then we'll go down to the positive 1 and multiply positive 1 times x, and that goes in this corresponding box. So positive 1 times x is simply 1x. And finally, positive 1 times positive 2. Positive 1 times positive 2 is 2. So the box is now complete, and we have to write our expression by adding each term together. When we do that, sometimes we can combine like terms, sometimes we can't. In this case, I'm going to write out the entire expression as if we could not combine them. So if we wrote out x squared plus 2x plus 1x plus 2, this is technically correct. However, we can combine these like terms, 2x plus 1x. So we have x squared plus 3x plus 2. And this is the final simplified polynomial when we multiply x plus 1 times x plus 2. Now I'm going to go back and explain a couple of things that you might have missed. First, we have to multiply x to the first power times x to the first power, which gives us x to the second power. Next, I want to make sure you notice that we added 2x plus 1x, and these are located in the diagonal of the box. You will find that this happens most of the time. If you can combine like terms, they typically are in the diagonal of the box. Otherwise, once we finished multiplying and we had all the values in the box, we simply added them together, putting plus signs between them. Our final answer is the simplified expression x squared plus 3x plus 2. So x plus 1 times x plus 2 is equal to x squared plus 3x plus 2.